Great. So, yeah, so I promised you guys we are going to make a little app that can retrieve the weather for a city from the internet. As part of this, we are going to learn about a package manager, package managing tool that allows us to use libraries or tools that other people have created in our own project very easily. And if there's updates, this package manager makes sure that all of that gets updated if we wanted to, or if we don't want it to update, that's also fine. Yeah, so the larger the application is that you are writing, the more likely it is that there's no way for you or for your team to make everything. So there's going to be you're going to be using other people's code in your profession as a software engineer, and a very good software engineer knows exactly when to reinvent the wheel and when to use someone else's cool stuff. And so as you're using other people's stuff, a couple of things. What are a couple of things to be aware of if you're using someone else's stuff? Who has an idea of what you might have to look for, especially if you're in an environment where you're making money with the software? Copyrights, license agreements. Yeah, make sure if you're using someone else's stuff, you might have to pay them for using it, or maybe it's free to use. The license agreements are there for you to know what you can do with it. But yeah, so in a large software engineering company, very likely for especially for very complex and specific things, you're going to be using other people's software. A couple of examples where, so I work at a small healthcare startup, and for example, we use third-party libraries for tracking. So we're tracking events that happen. So the user clicks through. We want to know what screens they've seen. We use a third-party library that someone else wrote, and we're using that. Other things, other third-party tools we're using. So we have a tool that allows us to turn on and off features as we're developing them. So we can start writing a new feature, and we can commit it into our code base without users necessarily being able to turn it on, but testers can play around with it. So for that, we use another third-party tool. So lots of areas where you're constantly using other people's stuff without knowing necessarily. So we're going to learn we're going to learn how to use one of the package managers that exists for the iPhone ecosystem. There are three major ones. So one that Apple created. That one's fairly recent. Support is not, so most libraries are not necessarily supporting this one yet. So yeah, there's I think it's called the Swift package manager. So that one exists, and then the two competing ones that other people just created because they needed a package manager. One is called CocoaPods, and then the other one I've only seen written. I don't know how to pronounce it. Carthage or something like that. They're different in their ideologies. So CocoaPods, you compile the source code. So you install. You're saying I want to use this dependency in my own code base. You get all of the source code files, and as you're compiling your application, you're compiling all of the source code files for your dependencies as well. The other one, you get binaries, so you don't have to compile them, but it can also be nice to be able to see all the source code files. So you can kind of learn from how they've done it. But yeah, so there's two different approaches there. I'm most familiar with the one that I'm going to show you, and that's the one where you can see the source code. In its main implementation, you can see all the source code of the files that you're using. Yeah, so the one that we're going to be learning about is called CocoaPods. Just cocoapods.org is their main website. So again, what does it do? It is a way for people to create a little tool or a library or extension, like functions, a collection of functions, and distribute them to other people. It's very simple to get started. So all you should be able to, you should just be able to run this command. It installs CocoaPods, and then you can use this package manager in your own projects. Cool. So the one library that we're going to look at today is called Alamo Fire. Apple has made it fairly complicated to make web requests. So as you're learning how to be a professional iOS engineer, you might want to dive into how Apple does it. You want to know all the nitty-gritty stuff of how to make web requests. But like for someone who's just getting started, I find it very confusing and hard to make web requests. So Alamo Fire is a library that wraps all of Apple's networking tools and turns it into a very neat interface. It's much more friendly to use and yeah, so lots of people out there are using it. So if you're deciding whether or not to use someone else's stuff or not, there's a couple of areas to consider. So one I mentioned is the license agreement. So a lot of CocoaPods are hosted on GitHub. So GitHub, most GitHub repositories have a license agreement. So so this one's the MIT license. At some point, you maybe read through MIT, Apache. Those are often licenses used for open source projects. So these are fairly these are the most liberal ones that you can use. Yes.
But is there a difference between this one, the MIT license, and GNU license?
So at some point I knew all the differences. I compare them yourself. I don't remember the exact differences, but it should be spelled out here pretty clearly what you can do and cannot do. So a lot of the open source ones, you can use them even if you're making money with it. They just want you to attribute that you're using it. So somewhere in your app, put a little about section and just say, hey, this uses this library. Cool. So yeah, license, one big thing to consider if you're using someone else's stuff. Do I have to pay them? Can I, if I don't have to pay them, do I have to make my software free? So those are good things to consider. The next thing is how active is the community around this tool that you're using. So especially at the beginnings of Swift was going through a lot of fairly drastic changes. So from Swift 1 to Swift 2, you pretty much had to rewrite your application. If you were using a library that was written in Swift 1, you probably couldn't use it in your application anymore. So you relied on whoever was maintaining this library to also then go in and update it. So the more people who are using it, the more active one of those libraries is. Those are good signs. So let's see. So if we're just looking at the GitHub commits here, someone committed something here 7 days ago. So that's a really good sign. Lots of usage. Lots of changes. You can really geek out here and go into how commit frequency, and those are good things to look at and see especially if you're writing a software application that needs to be very up to date with security stuff, and so choose libraries that are well maintained and have a great community around it. Another thing to consider is how is the community receptive to bug reports? So you can kind of research Do they have do they have tickets that are issued? Are people working on those? How easy is it? So if you find something that you want fixed, how easy is it to just contribute? So those are potentially factors. And then one really quick way to see the health of a community is on GitHub is the stars here. So how many people have starred a repository is a good quick indicator, and also so how many people have taken this library and have like made their own little changes to it. So forks are when you take a repository, you start fresh and you can make some changes. So those are all good indications that. So 32,000 stars for a Swift library. That's a really active community, and so lots of people are using this. So Alamofire is the first outside dependency that we're going to be using today in our CocoaPods dependency management example here. Cool. So something that most of these libraries have is a section where it says how you can install it. So for CocoaPods, there's this little command that we'll make light off in a second, and then so there's the other competing package managers here. So no idea how to pronounce this. Carthage? I don't know. So yeah, there's different ways to. So the Swift package manager. But yeah, we'll be using CocoaPods. So this line is going to be interesting to us in a second here, and we'll digest it bit by bit. Okay, so yeah, installation, and then often there's so a good, well-maintained library should also have some documentation. So this one has a great section on how to actually use this library. So if you're considering adding a dependency to your project, it's a good idea to make sure that it's well documented. It's really frustrating to try to do something with a like third-party software and you have to hunt down how it works, reverse engineered. So it's really frustrating. Great. So yeah, Alamofire, we're going to be using that in our project. So how do we actually make this work? So yeah, so I already have CocoaPods installed, so I don't have to run this command here for installing CocoaPods. But yeah, so if you are trying to get this to work at home, which I highly encourage you to get set up with CocoaPods and browse what's out there, you'll have to run this. Quick note here: it is really simple to create CocoaPods yourself. So if you have like 4 or 5 projects that you're working on, and you see that you constantly use the same helper methods and helper classes or whatever, it's really quick to create your own CocoaPod library and upload it, and then you can use it in your other projects. And you can, if you write good documentation around it, maybe someone else finds it useful as well. So, and it looks really great on a resume if you have a library that you created and people are using it. So. Anyways, and definitely employers look on GitHub. So if you have, even if people are not using it, if you can show that, oh, I've created all these helper tools, that employers are looking at that. Cool. So how do we get Alamofire into our app? So for that, let's start fresh. So we don't need our phone book anymore. So new project. We'll start with a single view application, as always, and we'll call it City Weather App. Great. Okay. So we have our regular app, fresh clean app. We actually now have to go to the directory of our repository because we have to make it ready to accept our CocoaPod. So I have it on the desktop here, and I need a command line. So that has been doing that. Okay, So terminal is the one that comes with the Mac, but you don't need. I use one called iterm, and so bash comes with terminal. That's the shell. I use a shell called Z shell. So it might look slightly different for you when you're doing this, but it's mostly how it looks at the beginning here. So yeah, you'll need a terminal. We need access to our main folder where the project file is located. So we want to change our working directory for our shell here to this directory. So I could navigate to this right now. There's a handy little way of copy. So if I'm in this folder in Finder, if I press Command, Option, and C, it copies this directory. If I have a file selected and do Command, Option, and C, it copies the directory. It copies the file path for this file. But yeah, so I just want the directory for this window here, and I want to change the directory to it. Cool. So now I'm in this directory. I need to now I need to initialize this project as one that can work with CocoaPods. So very simple command. Oh, I think I can make this larger. 1 second. Is that better? Yeah. Okay. So yeah. So just change the directory. So CD for change directory. And then just in case there's spaces, if you paste what you copied with quotation marks, it'll actually change into that directory. So now I want to initialize I want to initialize my project to accept CocoaPods. Very simple pod init. Init. Initializes my my directory here. So what did this do? So all it did, it created this pod file for me. The pod file is the list of all the dependencies that your project has. So let's take a look inside. Anything with a hashtag in front is a comment. So we don't need this here necessarily. Oh yeah, so let's remove all the comments for now. We can specify a platform here. So if we remove this comment, we would say the minimum requirement is iOS 9. That might be necessary if one of your dependencies requires a certain version, but most of the time you don't need to specify this. That's why it was commented out. I'm just going to remove it because it's confusing and it was already commented out. I'm also going to remove this comment. I'll talk about it real quick. This is most CocoaPods require you to have this line. It uses frameworks inside the. It uses some of Apple's frameworks. I'm not quite sure what it does. You just need it. Let me. Yeah, let me talk about the rest that we have here. So we're not using tests currently. So we haven't talked about unit testing yet. So we can also remove this line as well. We don't need it yet. Once you're writing your own unit tests and you want to have access to that dependency, you would use that. You would keep that as well. So pretty much the only thing we need to make this work is we need to specify the target for which we want this dependency to work. So city weather app is this is our project target. So the target is up here. So city weather app. You'll also see it in the project file. So you have targets here. So city weather app, and then the other target that we just deleted was the city weather app tests. So we need to specify the target for our for our pods. So you can't just copy a CocoaPod a pod file from one project to the other. You have to update which target you want to install it in. So yeah, so this is the empty shell of a CocoaPod of a CocoaPod pod file. Now we want to take the dependency that that we want to install, which is right here. So we want to just we want to tell the pod file to use this dependency. So I'm just going to copy this for now, and I'll talk about what we're doing here in a second. I think I can make this larger as well. Great. So pod just says you're declaring a dependency. This is the name of the dependency, and we could theoretically remove this, and this would use the most recent version that it can find. And if you it doesn't lock it to a specific version. It just takes whatever's there. You might have to, if there's some breaking changes, you might have to do some updating. So here's some notation where we can specify a version. So this means we want at least this version. So most of the time versions look something like this. So there's a major, a minor, and a patch version. So Almafire has a version 5 point something out. I guess they have some sort of revision here, so we'll have to. This one kind of looks funny right now. So most of the time it looks a little cleaner like this. If you really want to lock it down to one specific version, you can add the equality sign here, and then especially if you're working with multiple people on a project, I would encourage you to use the equality sign here. So this way it is locked into this version. So there's no chance that two of you guys are working on a project with different versions of this. So let's save this, and so now we have specified the dependencies that we want to use for the target that we created here with our empty project. So our main target is now going to use this. So now we can actually install all those dependencies. So that also goes very quickly, and it's very simple. So pod install runs, goes out, downloads the dependency. So it installed Almafire, this version. It generated a pods project. I'll go over in a second what that means. And everything is green here. We have some orange here. Oh, why didn't you fit on the screen? Yeah.
So if someone was to download this app, how would it just be within the downloads through this?
So you're saying if I'm download, so the way that a user would download the app is through the App Store. So if you submit this app to the App Store, it is packaged, so it's compiled into binaries, and it's all integrated. So you don't have to worry about any of this for shipping it. It just manages all of that for you. If you were to distribute your source code and for other people to be able to run and modify your project, you would have to tell them that they have to install CocoaPods and run pod install. Yes.
So does Apple know how many CocoaPods are in the app? Check all the libraries that you're building?
So yes, they do. They actually know a lot about what you're doing. So they sign. So the way it gets compiled is it doesn't get straight compiled into your project. It gets compiled as frameworks, and then so it also makes it so that if a dependency uses two different dependencies use the same dependency, it doesn't import it twice. It just imports it once. So Apple knows how many frameworks you have used. And Apple also knows, Apple actually knows a lot about what you're submitting. So for example, so the most recent time I submitted something, I got a very nice warning by Apple that, so I've been using the UI WebView component, and it is currently deprecated, and very soon Apple will stop allowing me to submit this app unless I remove the UI WebView component. So they know what you're using, yeah. So I mean, it's one of the reasons why there haven't been any, and to my knowledge, any viruses for the iPhone, or no like widespread Yeah. So yeah, so Apple knows what you're doing. Anyway, so yeah, pod install installs your pod all your dependencies, and so there's a couple of things that happened just now. So I had the project open. I actually can't use this project anymore, so I have to close this, and I'll see what I'll show you in a second what I have to do here. So I don't know. I guess I should have pointed out how this looked beforehand. So beforehand, before I ran pod install, we had this directory. We had the city weather app Xcode project. We had the tests file, and that was it. So we had these three files and directories. So what is now here? So when we ran pod init, it created the pod file. And when we ran pod install, it created this workspace file, the pod log file, and it created this directory. So let's go through what each of these do. Let's start with the pods directory. These are all the dependency files. You never have to touch this. You don't want to modify anything here. If you're updating, if you want to update your pod, you change the version in your pod file. So let's say that 5.1 comes out. I change this and I run pod install again. So pod update does something very different. You always want to, if you're changing a version, always pod install. So before you use pod update, just read what it does. The only things you kind of need to know is pod init and pod install. So yeah, so the pods directory has all of your has the dependencies that you just installed. So we can drill down in here, and so yeah, Alamo Fire is here, and as I said, we can look into we should be able to look at each of the we should be able to look at how they have implemented it. Okay, so yeah, the pods directory has, it's actually here, sorry, source, and so yeah, a very good way to see how other people are writing code, if you want to look for good examples, pick a library that is well used and just go through their code files. So there's some great for like documentation. How should I document my code? How should I organize my code? Looking for code style, looking for ideas. I love going through libraries that are well maintained. So yeah, the pods directory, that's where your pod, all of the source files live. The pod log file, let's open that one and take a look what that does. So the pod log file has, so we see a checksum here. So this is a hash. We've talked about hashes earlier today. It checks that whatever the dependencies that you have match what you say should be in your pod file. So it's a way for you to, if you're working with multiple people, each time you compile your project, it makes sure that the dependencies that are there match what is there, and it'll tell you to run pod install if something's out of sync. So this is very helpful in working with other people. It's not that helpful if you're just working by yourself. Yeah, so the checksum is there, and then actually it has, so right now we just have one dependency that doesn't have any sub-dependencies. If you have 4 or 5 dependencies, there's a good chance that they have sub-dependencies, and then here there's your entire dependency tree listed with all the sub-dependencies. So the pod log file locks in all of the sub-dependencies for you. So you never want to edit the pod log file. The only file you want to edit is the pod file that we've already edited. Okay, so yeah, so normally we've been using the Xcode project file. We cannot use that anymore. We now have to open the Xcode workspace. A project is just that. It holds one project. A workspace can hold multiple projects. So it's a collection of projects, and that is going to make sense in a second when we open this here. So let's actually open both side by side here. We can't open it because it's open in another workspace. So in the other, if we were to open the project file, we would just have this folder here. So this was minus, before we ran pod install, we wouldn't have had the pods directory here. So it would just have this. the workspace adds a pods project to your Xcode workspace, and this is where it manages all of the dependencies. So this is how. So it doesn't copy all the source code into your project. It kind of manages that separate from your project. So it's very nice. You don't ever have to really interact with third-party libraries where there's a chance that you might mess something up. The pod file you can easily access from here as well, so that then you don't have to navigate into the directory. Great. So that is all we needed to do. So maybe just a quick refresh. So we installed CocoaPods. You just have to do that once. We went to our terminal. We changed the working directory to our project files directory, and we ran pod init, and we added the dependency to our pod file, and then we ran pod install. So very few steps. Yeah. So run pod init, add the dependency, run pod install. That's all you need to do, and you can use other people's libraries. I find it very easy to use. Great work these people have done. Cool. So let's actually make something. So I think, yeah, as I said, I think we won't have time to. We have about half an hour right now. So let's make sure that we see something from the internet, and then let's spend some time next week to make it maybe a little bit nicer. So what do we want to do? So we want to retrieve the weather for a city from the internet. Last year, I was still able to use Yahoo's weather API, which was very nice. We could just I could just input the name of a city, and it would give me the weather back. As I was trying to get this ready for this week, I realized Yahoo shut down their weather API. So what we have to do now is we have to use this. The only one that I could find that wasn't horrible to use is this one. It has the caveat that we have to use latitude and longitude, and we can't type in the name of the city. So we'll make this work. Maybe on your own you can see if you want to modify this. Maybe you can find an API that works better. Great. So what do we want to do? We want to call this. Let's see. I'll just copy this. Okay. We want to be able to so we want to be able to call this URL. We have our URL here, and then we have two query parameters, latitude and longitude, and I've already made it such that we can insert our strings here. So I googled San Francisco's latitude and longitude. So great. So we have San Francisco's latitude and longitude, and we have our URL string here where we're passing in latitude and longitude as parameters. So hopefully there's nothing new here. We're concatenating, or we're building a string with two parameters. We've seen that a lot, and this is the URL that we want to call. Okay, so how do we actually make a request to the internet with our Alamo-Fire dependency? So right now, what will happen? We're putting all of this into view.load. So this is like a quick way for us to test this out. So let's whenever the view loads, we'll see if this works. So before I can use a dependency, I have to import it. So any CocoaPod that you install, you'll have to include an import statement in each of the class files where you're using it. So import Alamo-Fire, this wouldn't have been we wouldn't have been able to do this before we ran pod install. So pod install gave us access to this framework, the Alamo Fire framework. Great. So we are now actually pretty much following the documentation for making a request. So there's great documentation. I'm going to do a very minimal job. So Alamo Fire has lots of powerful features. My intention here is to give you an alternative for Apple's horrible networking APIs with a quick way to get something back. So if you're interested, there's way more to dive into. We just don't have a lot of time to actually dive into it. So, but yeah, lots of Alamo Fire does lots of great things, and then yeah, maybe also on your own, something to look into is Apple's APIs for making requests. Great. So how do we make a request to the internet? So Alamo Fire, so af.request. So URL convertible is just, so let's see what URL convertible is. So it is something that can be turned into a URL, and somewhere just below it, they added an extension to the string. We haven't really talked that much about extensions. We'll do that a little bit later, but you can extend any type in Swift with your own functionality. So the people who made Alamo Fire created this protocol where a type can have a function that turns it into a URL, and then they extended the string to be able to turn it into a URL. And then so the nice thing is, because we have access to their source code, you can see how they did it. So that's the nice thing about working with these libraries. If you're working with Apple APIs, you have no idea how they implemented things, because it's all compiled, and you're just working with the interface files. But yeah, here we can see how they implemented it. Great. So we now know that we can pass in a string into our request method here, and it'll get turned into a URL. So the thing this will turn into is it will turn into here we go. So there's a URL type that is defined. This one is defined by this is a Swift type. So the URL type holds holds requests not requests. It holds addresses to the internet with query parameters or not. And the string that we created here gets turned into a URL. Okay, so we're making a request. That is good. We can now specify what kind of a request this is. The default is a GET request. So hopefully you're at least a little bit familiar with how the request to the internet works. So there's GET, there's POST, there is patch, there's delete. So we can define a method for making this request. So method. As I said, GET is the default, so this is a little bit redundant, but I just wanted to show you that you could, if you're trying to make a POST request, this is where you would do it. So yeah, we have our URL string, we have our method, and now we want to get a response back. So there's lots of very neat ways how you can get a response back from Alamo Fire. We haven't really talked about serialization and deserialization much, so where you can turn an object that has lots of nesting into a flat serialized string and turning it back into an object. We haven't really talked about that much. We'll talk about maybe next week, maybe the week after. We'll talk about that a little bit more. So there's great functionality for making that a little bit easier. We are going to go the old school way, where we're turning whatever we're getting back into a JSON dictionary. That's why we started the lecture by looking at the dictionary. So we're going to turn whatever we're getting back from the internet into a dictionary. So we are doing response JSON. And this is where everything that we learned last week comes in handy. So we are getting a response back from the internet, and when we're getting a response back, this completion handler is being called. A completion handler is a fancy word for a function that we're passing into this function. So function as argument into another function. That's all that is here. So why is that necessary? How long does it take to make a request to the internet? If you are on a poor connection, potentially indefinitely until it times out. You do not want to block the UI thread. So as you're making requests to the internet, you want to make sure that you're not blocking the UI thread. Another thing that we're not covering today is, maybe we can make that, so you don't want to block the UI thread. So it makes sense that you want to be able to make the request to the internet and at a later time do something with the response. So that's exactly what we've done with the timer. So we set a timer, and when the timer is up, we want to do something. That's what we did with all the other examples that we've done, passing functions in as a parameter where time delay was the application. So again here, we're passing in a function as a parameter to another function, and we could again use an anonymous function here, or we can also define one. So func. Actually, let's use an anonymous function for now. So response. Okay. Okay. So yeah, we have we're asking the internet for a JSON response for this string, and we're getting a response back. And let's see what type this. Xcode is not letting us check the type of this right here. It is packaged in a way that we can see whether or not it was successful or not. If there was a 404 or a 500, or what kind of error code was there. So that is all part of the response. And then also, if there was data associated with this response, we can access that as well. So response.value is where we're getting the data back that we're asking for. So as you saw, the value is of type optional. So let's make sure that we actually do have God that. So we're going to ask for the value, and then the type is of type any. I've been saying whenever you can, avoid any. When you're getting JSON back, it's really hard in a strongly typed language to avoid any here, because you might have an array of dictionaries, or you might have a dictionary. So an array of dictionaries is totally valid JSON, and just a dictionary is also valid JSON. There's no real concept of that in Swift, so we have to check which one we got back. So we are actually, when we're asking the weather service and we're passing the latitude and the longitude, we are getting back just a dictionary. So let's see if. Great, thank you. We are going to do some typecasting right now. So we haven't really seen any typecasting. We've seen passing an instance of an object into a constructor of another one, and then that type had some logic for converting it. So we've seen some casting in that way, in that sense. So we've seen passing a string into the constructor of an integer, and then it might be successful or not. And so now we're actually doing some casting. So we're getting something of type any, and we're checking if we can turn it into the expected type. So as question mark as does typecasting. Question mark means if it fails, return nil, and since we're doing it in a guard statement, it'll just go into the else block here. So yeah, so as question mark, what do we want back? We want a dictionary back. So string any. So again, you're seeing any here because we're dealing with JSON. That's kind of the only time I really want to see any in any of your code is if you're working with JSON. And then there's also lots of convenient ways that you actually don't have to do it anymore that have been evolving in the last couple of years. Yeah, so what we're doing here is we're taking the value of the response and we're trying to cast it. Trying to do type conversion, type casting, into a JSON dictionary. So a dictionary with string keys and who knows what kind of values. So we're trying to do that. If this is successful, since we're doing it in a guard statement, we have access to this JSON dictionary file. Else, for now, we're just going to return. We probably want to do some error handling here normally. So to do error handling. Cool. So yeah, we have, so just recap real quick. AF stands for Alamo Fire. We're making a request using our neat dependency that we just installed, where we're passing in a string. We can specify the method. There's some other things that you could potentially pass in here, so I encourage you to explore the request method. And we're saying we want a JSON response back, and when we get it back, this anonymous function is going to execute. Inside this anonymous function, we're trying to get a JSON dictionary, and that's it for now. So let's see what we get if we make this request and print out this JSON dictionary. So there's another funny thing with this API. So let's see if it happens right now. To get San Francisco, I sometimes have to run it a couple of times. So we'll see. So I really am sad that Yahoo removed their weather service, their weather API. Great. So we got something back. Let's see what we got back. Okay, yeah. So we got we got something in, I don't know how to pronounce this. We got something in China back. So let's see if I run this again. If we get San Francisco back. I saw US. Let's see. San Francisco. Yes. So it worked. So it's a little glitchy. But I think it's good enough to demonstrate what we're trying to do here, and yeah, so maybe you can see if you find a better API to use. So yeah, this is the response that we got back, making the request with the latitude and the longitude for San Francisco, and we have this pretty complicated object here. So we have a JSON object that we got back with. So let's actually maybe put this into Sublime here, and smaller. There we go. Let's see what we have here. So so it looks like we have an ID, we have coordinates, we have visibility, we have base, we have name, time zone, wind. Okay, what else do we have? Oh, for wind we have degree, we have clouds, weather. Okay, let's see. And then, oh, this one belongs there. What else do we have? We have main. So where do we have temperature? Let's search for temperature. So it looks like in our main object we have to go into. Oh, sorry. In the base object we have to drill down into a main. We have to ask for the main key, and the main key has a temperature property. So that's what. So we have to do main and then temperature to get the temperature, and to get the name of the city we can just ask for the name of the city. So let's do that. So how would we do that? So we have our JSON dictionary here. We've seen already that we can, in our guard statements, we can do a bunch of conditional unwrapping by just doing a comma separate list. So we're just going to drill down into this JSON dictionary, get all the properties out that we want, if they can be assigned, and then if not, we have our error handling in our else block here. Okay, so let city name equals. So we have our JSON dictionary, and it looked like there should be a key called name. So we're going to get that back. And then let's go back here and see. So it's going to be a string. So since our dictionary has keys that are strings and values that are any, to be able to treat what we're getting back here as a string, we have to do some casting again. So we're going to say, is this a string? String. If yes, assign it to our city name property. So we're doing kind of the same thing that we've done up here. We now have a dictionary. We're accessing the key name, which is of type any, and we're doing some conditional casting to a string. If it's successful, it'll be assigned to our property city name. If not, we're going to hit our else block here. So let's see if that works. Instead of printing out the entire JSON dictionary, let's just print out the city name. So let's see if that works. San Francisco. Okay, so that worked. Great. Maybe before we go any further, it's kind of annoying that we have to. I guess we have 12 minutes. Okay. Let's build a really quick user interface so that we don't have to print this out constantly. So let's for our view controller in our main storyboard. Let's just create a field real quick for our name. So we have a label for the name. Oh, actually, so let's create a label that says what it is, so name. Then we'll add a label where the name of the city is actually displayed. Then let's do another label that says temperature, and where we're actually displaying it. I won't set any of the layout constraints right now. I'm constrained by time, so it'll work fine on this device without us rotating it. But yeah, so theoretically we would have to create some layout constraints. Actually, this might not work, so let's just make it slightly wider. Great. So yeah, we've seen lots of layout constraint settings. So maybe at home you can make this a little bit prettier. Great. So let's create outlets real quick for the name and temperature. So in our view controller, let's control drag the name label and the temperature label. Great. And so now, so we don't need our interface builder file anymore. So let's see if we can print out the city name and the city temperature in their respective labels. So we have our name label and our temperature label as properties on our view controller. And we're trying to access them in this anonymous function. So we're trying to access something that's on the outside of the function. So outside of the scope of this function here. That is fine. We can do that. So anything that's outside, if we access it inside this function, it gets captured. So we have access to it. It comes with a couple of caveats. So the way we're going to use it today, it is safe, but 3 or 4 lectures from now, we're going to see how this can go horribly wrong. So what we're doing right now is fine. As we're trying to access this property, the compiler is going to tell us to do something very specific, and there's a reason why it's doing that. So just keep that in the back of your head. There's going to be a little bit more that we have to unwrap here. So let's try to access the name label, so the way we would normally do it. So we're inside our anonymous function here. So name label.text equals city name. Okay, let's see if we can build this, and we can't. We're getting a compile time error because there's something that we don't really know yet here, and it's okay. We don't necessarily need to know it quite yet, just for you to know for the future. So reference to property name label in closure requires explicit self. No, and then so yeah, that's pretty much all. There's some other text here. I'm not sure if I can get it. Requires explicit self to make capture semantics explicit. So it's a little bit of a jargony way of saying we are capturing, or we are to be able to assign something to this text label here, because it's outside of the scope of the anonymous function. We have to capture the label. We have to capture the variable that's outside of this. So we have to keep a reference to it. So that's what this is saying. So it's saying we are, by accessing this property, we are somehow making sure that we will be able to access this when this function gets called. And as I said, there's something dangerous about this that we are not going to run into right now. Because we are on thin ice here, we have to add, so reference to property name label enclosure requires explicit self. So this is what we need to do. So we need to add self.namelabel.text. So now it is very explicit that we are accessing something outside of the closure, and we're adding the property here. So there is some danger with what we've done here, not in the way we're using it right now, but again, so we have to re-examine this in a couple of lectures. Let's see if this works. Okay, so did the Chinese city again. Who knows how to pronounce that? Shanji. Okay, so did it again. Again, sometimes it does San Francisco. Okay, not right now. Well, you've seen it work. Okay, it's not wanting it right now. But yeah, so this came, even though it's not San Francisco right now, it came from the internet. So we did a thing. We asked the internet to give us something, and we are displaying it. So that is already pretty amazing, I think, and it's pretty simple. So if we were to do this with the Apple APIs, this would be quite a lot more complicated. Great. So we just have 5 more minutes. Let's just make sure that we can also drill down and drill into the dictionary and get the temperature as well. So we had to get the main element. So main equals so main, and then so what do we have to cast that as? So let's see real quick. So where was main? So it looks like it is another dictionary. So main is the key, and then we have another dictionary here where so humidity is the key, and then it has a value, humidity, pressure, temperature, temperature max, temperature min. Okay, so we don't want this main. We're accessing the main. We're accessing the dictionary, whatever is stored under the main key, and we want it to be another dictionary. So instead of a string, we are going to have to try to cast it as a string and any again. Okay, so now we have access to this. Oh, where is it? To this structure here. So here we can now access temp. Now we want to access temp inside our main element here. So okay, so let temp equals main temp, and then that we can try to cast as a double, it looks like. So, oh, but it has quotes. Let's just cast it as a string for now. Let's see, we might have to. It's probably fine as a string for now. So great. So we now should have access to our temperature. Self.temperature label.text equals temp, and let's see if that works. It does not. Why does it not work? So we didn't have any error reporting. So this is where it is biting us in the butt right now, because just nothing happened. So one way of knowing that an error happened, we could print something to the name label. So let's just do that for now. So error. Very crude error handling, but oh, good enough for now. Okay, so we have an error. Let's see what's going on. We haven't really talked about debugging much. We can very easily set a breakpoint in our completion handler here by just clicking in the margins. If I click it again, it becomes a highlighted blue, which means that it's inactive. If I want to actually remove it, I can drag it out. Okay, so let's see what happens. Let's run it. It is going to stop execution at line 18. And now we can go line by line. So the third from the right here means line by line. So it could. So it was able to go into line 20. So we're now in line 20. So we have access to our JSON dictionary. We were able to go into line 21, which means we have our city name. We were able to go into line 22, which means we have our main dictionary, which means that this line, I guess, has to fail. So let's see if we can access what we have here in our dictionary. So one way you could here's all the values that you can drill into. Another way you can access it in the console. You can type in PO and then whatever variable you have here, and then enter. And so PO for printout, and it gives you access to it. So yeah, so we have our dictionary, and it looks like so there's a temp key. I am confused as to I'm confused as to why. Oh gosh. Okay, we have 1 minute to solve the problem. Let's see. If I'm looking at my notes, I actually cast this as string and double. That must be it. And then I didn't have to do this. Okay. I guess I could. Yeah. So I guess I could also, since we had it like this. So it was a double. It wasn't a string. Let's see if we. And I think I just ran out of time, but ideally this should now work. There we go. So we didn't get San Francisco. For some reason the API is flaky, but we got our temperature and our name. Sorry for, again, cutting it close here. I just wanted you guys to actually have a thing at the end. Yeah, I'll post the lectures. We'll continue next week. Thank you guys for coming.